Welcome to our deep dive. Today we're going to be looking at how AI is tackling math. One of humanity's oldest academic disciplines. Pretty fascinating stuff. And you're here because you want to know how these systems are being developed, what hurdles they face. Well, to do that, we're going to be dissecting a recent academic survey paper. It analyzed over 200 studies on math-focused large language models, or Math-LLMs for short.
Yeah, Math-LLMs, they're not just solving for X anymore.
Right. It's way more than that.
What's fascinating to me is how these AI systems are proving theorems, solving geometry problems. And we might even learn something about how we learn math by studying these systems.
It's really mind-blowing stuff. And you know what? This field is exploding. Right now, figure 2 in the paper, it shows a massive spike in the number of Math-LLMs being developed since 2021. Why is that happening now?
Well, it's building on the advancements we've seen with large language models as a whole. But what's unique here with Math-LLMs is that we're creating specialized models trained on vast amounts of mathematical data.
Like what, for example?
Well, there's one called Zhuzheng.
Zhuzheng.
It's actually named after an ancient Chinese mathematical text.
Wow.
It's almost poetic. AI is drawing on centuries of human mathematical understanding to create new solutions.
I love that. So we've got these powerful AIs crunching numbers, but how do we even test their abilities? How do you give a machine a math exam?
Great question. Researchers have been working on that. They've developed these sophisticated benchmarks to evaluate Math-LLMs.
Okay.
Figure 3 in the paper shows what this looks like.
Okay.
You have the input, which is the math problem itself, and then you have the output, which is the AI's solution.
Right. Makes sense.
But here's where it gets interesting. These benchmarks need to handle the various ways we represent math. Not just text, but images, diagrams.
Yeah.
Math isn't just about numbers. It's about understanding complex relationships.
So it's not just like a standardized test, with multiple choice answers. Nope, not at all. The paper highlights a key distinction between what they call discriminative and generative tasks.
Okay, discriminative, generative. Discriminative tasks are like those multiple choice questions. The AI selects the best answer from a list.
Yep.
Generative tasks are more complex. The AI needs to produce a full solution and show step-by-step how it arrived at the answer.
So they have to demonstrate their reasoning process.
Exactly. And that's how researchers are getting closer to seeing if AI might actually think like a mathematician.
So it's not just about the right answer. It's about the how and the why.
Exactly.
Okay, so are all these Math-LLMs just trying to solve equations? Or are there different ways they're being used in research?
Good question. The paper actually outlines 3 main paradigms for how these Math-LLMs are being used. LLM as reasoner, LLM as enhancer, and LLM as planner.
3 different approaches. That's really intriguing. Let's start with LLM as reasoner. What's that all about?
So in this paradigm, the Math-LLM is being trained to directly solve problems using its knowledge and its reasoning skills. Imagine it like a top student tackling a complex exam question. They rely on their understanding of the concepts to find the solution.
So the AI is flexing its mental muscles.
Yeah, basically.
Trying to solve things on its own. Are there specific examples in the paper that illustrate this?
There are, yeah. One example is called masked thought.
Mask thought.
Yeah, the AI is trained with solutions that are partially hidden.
Oh, interesting.
So it has to fill in the gaps.
Yeah.
And by doing that, it learns the reasoning process.
So it's like giving the AI a puzzle with missing pieces.
Exactly.
Okay. What about LLM as enhancer? Is that where the AI helps other AIs get better at math?
You got it. Instead of solving problems directly, the LLM in this case is focused on improving the training data that's used for other models. Think of it as an AI tutor creating study materials for other AI students.
Oh, that's a cool way to think about it.
One example mentioned in the paper is Math Genie.
Wow.
It's an LLM that can actually generate new math problems and solutions. So it expands the training data sets that are used to train other Math LLMs.
Oh, it's like a textbook that just creates endless practice problems.
Yeah, exactly. And they can be tailored to the specific learning goals.
So it's like personalized math education, but for AIs.
Yeah.
Yeah.
In a way.
Wow. Okay, so we've talked about reasoner and enhancer. What about LLM as planner? That sounds like the most complex of the 3.
Yeah. This is where things get really interesting. The LLM acts as a coordinator.
Okay.
It breaks down these complex problems into smaller, more manageable tasks. And then it delegates those tasks to other models or tools.
It's like an AI project manager.
Yeah, exactly. Overseeing a whole team of AI mathematicians.
Okay. Now that's next level stuff. Are there any real-world examples of this kind of AI teamwork?
There are, yeah. The paper describes a system called Visual Sketchpad.
Visual Sketchpad.
The LLM in the system can actually use external tools to generate sketches to help it with the reasoning process.
So it's like the AI is using visual aids,
Yeah.
like we might do when we're trying to solve a problem.
Yeah, exactly.
That's incredible. It seems like we're really starting to see AI mimic human problem-solving strategies. But I'm sure there are limitations. Even with all these advancements, AI isn't perfect.
Right, of course. And the paper actually talks about the challenges that researchers are facing. It identifies 5 key areas where these math LLMs still need to improve. And the first one is visual reasoning.
So being able to understand those diagrams and geometric shapes that we were talking about before.
Exactly. A lot of math problems rely on understanding visual information. It's one thing to read a theorem. It's another to actually visualize those relationships.
Right.
Like solving for missing angles, for example. Current models might be great at manipulating symbols equations. But when it comes to seeing and interpreting visual information, there's a lot of room for improvement.
It's like they need to develop their math eyes.
Yeah, you could say that. What's interesting is the second challenge. It's about going beyond just text and vision. Math problems in the real world, they can involve a lot more than just words and images.
That's what I find so interesting is like AI needs to become a multi-sensory learner, to understand things like audio explanations or even interactive simulations.
Right. It's about handling a much richer set of inputs to really grasp the complexities of math as it exists in the real world.
Okay, so we've got visual reasoning, we've got multi-sensory learning. What's next on this list of challenges?
The third one is domain generalization. Math is a vast field.
Huge.
And math LLMs that are trained on one type of problem, they might struggle with other types.
So an AI that's great at algebra might bomb a geometry test.
Exactly. They often lack the flexibility to transfer their knowledge and skills across different areas of math.
We don't want a one-trick pony. What's challenge number 4?
Number 4 is all about error feedback.
Okay.
Just like human students, AI needs to learn from its mistakes.
Of course.
But current systems don't really have a good way to detect and correct those errors.
So it's not enough to know that they got something wrong.
Yep.
They need to understand why and how to fix it.
Exactly. It's about developing AI that can analyze its own reasoning, identify those errors, and then course correct.
So it's like we're asking AI to become its own math teacher.
Yeah.
All right, so what's the 5th and final challenge?
The 5th one focuses on this gap between how AI solves problems and how humans learn. The paper really stresses the need for greater real-world relevance in these math LLMs.
So it's not just about getting the right answer.
No.
It's about solving problems in a way that makes sense to us humans.
Exactly. It's about developing AI that understands the nuances of human learning. You know, how we use those visual aids, how we break down problems step by step, how we learn from our mistakes.
It's like we're not just teaching AI to do math. We're teaching it to think like a mathematician.
Right. It's about developing AI that can actually enhance our own understanding of math and the learning process.
That's an amazing idea. That's truly incredible. We've covered a lot of ground here, from the rise of math LLMs to the challenges they face. This field is clearly evolving at an amazing pace, but I'm sure there's so much more to explore. What else can you tell us about how researchers are actually tackling these challenges?
Well, let's dive into some of the specific methods they're using. So one approach that I found really interesting in the paper is this idea of using neurosymbolic methods.
Neurosymbolic, okay.
It's basically combining the strengths of neural networks,
Right.
which are great at pattern recognition, with symbolic AI, which is really good at logical reasoning.
It was a hybrid approach.
Yeah, exactly.
Yeah.
It brings together that intuitive learning of neural networks with the more structured kind of rule-based thinking of symbolic AI.
So it's like we're teaching AI to see the big picture and the details at the same time.
Yeah, that's a great way to put it. This kind of blend allows the AI to tackle those intuitive aspects of math, like recognizing patterns in geometric shapes, but also that more formal rule-based side of things, like manipulating algebraic expressions.
So it's getting a well-rounded math education.
You could say that. And the paper actually gives some specific examples of this in action.
Like what?
Well, there's this one system where they use neural networks to analyze visual features from geometric diagrams, and then they use symbolic reasoning to apply geometric theorems to deduce solutions.
So they're working together.
Yeah, exactly. It's really cool to see how those different modes of thinking can work together seamlessly.
It's like the AI is using both sides of its brain. Right. Yeah.
That's a good analogy.
So what other techniques are out there? What else are researchers exploring?
Well, another really fascinating area is using external tools and knowledge bases to boost the reasoning capabilities of math LLMs.
Okay, so like giving an AI access to a giant library of math stuff.
Yeah, exactly. Formulas, theorems, problem-solving techniques, you name it.
It's like a super-powered math textbook.
Exactly. And the paper talks about examples where they've integrated these math LLMs with something called computer algebra systems, or CAS for short.
Yes, okay.
These CAS systems are incredibly powerful. They can perform all sorts of symbolic computations, solve equations, generate proofs, things like that.
So the AI is getting help from another expert.
Yeah, exactly. By tapping into those external resources, the AI can solve problems that it wouldn't have been able to before.
That's awesome.
Yeah.
What other innovative approaches are being explored?
Well, researchers are even working on figuring out how to incorporate human feedback into the learning process.
Oh, wow. So it's not just about AI learning from data.
No.
It's about learning from us.
Exactly. The paper talks about this technique called reinforcement learning from human feedback.
Okay.
So the AI is actually trained to improve its performance based on input from human mathematicians.
So it's like having a personal tutor for the AI.
You got it.
I love that. It's not about replacing human mathematicians.
Yeah.
It's about humans and AI working together.
Exactly.
So with all of this amazing research, what does it mean for the real world? Where are we actually going to see these math LLMs making a difference?
Well, one area with huge potential is personalized education.
Oh, yeah.
Imagine having an AI tutor that adapts to each student's learning style,
That would be incredible.
providing custom explanations, practice problems, feedback,
No more one-size-fits-all math classes.
Right. It could totally revolutionize the way we learn math. And it's not just for students. Math LLMs could also help teachers
In what ways?
by helping them create more engaging lesson plans, grade assignments more efficiently, identify students who are struggling, things like that.
So it's like having an extra pair of hands in the classroom.
Yeah, and incredibly efficient ones at that.
So that's education.
No.
What about outside of the classroom? Are there any other applications for math LLMs?
Oh, absolutely. There are so many possibilities. One that's really exciting is research and scientific discovery.
Okay.
These math LLMs could assist mathematicians in proving complex theorems, developing new algorithms, making groundbreaking discoveries in fields like physics or engineering.
Yeah.
You know?
Wow. So it's like AI is becoming our co-explorer.
Yeah, I like that. And the potential applications go even further than that. AI could help us make better decisions in our everyday lives.
Now we're talking bring it out of the lab and into the real world.
Exactly. Things like personal finance planning trips, even making healthier choices. AI could use mathematical reasoning and optimization techniques to offer us personalized recommendations and insights.
It's like having an AI advisor.
Right. Helping us make smarter, data-driven decisions.
So this is all incredibly exciting. But are there any potential downsides? As these math LLMs get more advanced, could they start to challenge our understanding of what math even is?
That's a really interesting question. And it's definitely possible. Imagine an AI that discovers new mathematical patterns or relationships that humans have never even considered before.
Wow.
Or what if it develops entirely new problem-solving strategies that are more efficient or more elegant than anything we've come up with?
That's both exciting and a little bit unsettling.
Yeah, it's true. Because it really would be pushing the boundaries of what we thought was mathematically possible.
Right. And by watching how AI tackles these problems, we might even gain new insights into our own cognitive processes. How we learn and how we reason.
Absolutely. It's like AI is holding up a mirror to our own minds.
That's a great way to think about it.
Helping us understand ourselves better. And that's what makes this whole area of research so profound.